Hello there, eager beavers. Today's video is section 1-4, solving absolute value equations. And before we start solving equations, we're going to do a little bit of evaluating with absolute value, just kind of freshen up here. So in this first example, it says to evaluate 8.4 minus the absolute value of 2n plus 5 if n equals negative 7.5. So we are going to replace n with negative 7.5 and then evaluate this expression. So 2 times negative 7.5 is negative 15 plus 5, rewrite everything else. Negative 15 plus 5 is negative 10, and as you probably already know, the absolute value is always positive. So the absolute value of negative 10 is positive 10, but there is still a negative in front here. This is still subtraction. So we are doing 8.4 minus 10, which will give us negative 1.6. And that is how you evaluate with absolute value. So now you can try these two examples, and then we will proceed to the actual solving process. And here we have an example. A standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of an adult tennis racket. So at first sight, it kind of seems kind of scary, all the words, but we could probably figure this out mentally. And then proceed to write and solve the absolute value equation. If an adult tennis racket has 100 square inch head right here, and then it says plus or minus 20, that literally means that it can be bigger than 100 by 20, or it can be smaller than 100 by 20. So we kind of already know that the boundaries, okay, for this value are that it's going to be somewhere between 80 and 120. If we decrease the size of 100 square inches by 20, then we get 80. If we increase the size by 20, then we get 120. So somewhere between 80 and 120 is going to be our answers. But it doesn't say to solve the problem mentally. It says to actually use an absolute value. So I kind of want to give you a little bit of I don't want to call it a trick, but kind of how I do this. I always do absolute value variable minus the center or the middle, and then equal distance from center. This is a nice little tool that you can use. You're probably aware that with absolute value, one of the definitions that we use back, when you're barely starting, I'm thinking maybe 5th grade or something like that, is they define absolute value as the distance from 0. In other words, on a number line, 0 is considered the center. So if I say something like the absolute value of x equals 2, it's saying that my distance from the center is 2. And in this case, my center being 0. So we know that the answers for this are negative 2. The absolute value of negative 2 is positive 2. And the absolute value of positive 2 is also positive 2. So x can actually be two different numbers. X could be negative 2 and positive 2. Both of those numbers tell us that they are 2 units away from 0 on the number line. And so you know how this works. Here's 1, here's 2, here's negative 1, negative 2. And you have 2 units away from the center. Well, what's happening here is that the center has kind of changed. Our center is not 0 anymore. So what happens if I take and write the expression instead as the absolute value of x minus 3 equals 2? What is that saying? That's saying that 3 is now my center. So if we go to this little guy, and it might not make sense right now, but now it's saying that 3 is my center. I want the distance from 3 to be 2. So if I have my number line, and we want to erase this little guy now, sorry there. So if I now have my number line, and I apologize for the lack of space here, but let's say that 0 is over here somewhere, and now I have 1, 2, 3, and this is now my center. And I am saying that I am 2 units away from the center. So that would be 1, 2, and I'd be at 5. That's 1 unit away, 2 units away, 1 unit away, 2 units away. So this would be 1, 2, 3, 4, 5. So 1 and 5. My answers would be 1 and 5. Algebraically, what that means is that I have to solve an absolute value, always solve absolute values with 2 cases, a positive case and a negative case. As we saw earlier, you could have positive 2 or you could have negative 2. That's why we have to use 2 different cases. So in the positive case, if I just solve x minus 3 equals positive 2, that's my positive case. I add 3, and then x equals 5, which we could already see from the number line that one of my answers is going to be 5. 2 units away from 3 is 5 on one side. But 2 units away from 3 on the other side is 1. And that happens by taking negative. The negative case means that you negate what's inside the absolute value bars. So I have negative x minus 3 equals 2. And this time I'm going to get negative x. And then negative times negative 3 is positive 3. I subtract 3. And I get negative x equals negative 1. And then when I divide by negative to get rid of that negative, I'm going to get x equals positive 1. And I apologize for the mess, but this is not the answer to our example. I just need to give you guys some background before we can get started with that. So we get x equals 1. So we already had the x equals 5 over here, and now we have x equals 1. But again, it was very easy to see that from looking at the number line. Here's my center, 3. 2 units away from the center is 5. 1 unit away from the center, or 2 units away from the other side is also 1. So we have 2 possible answers. So I hope that that kind of helps you see what I'm talking about when I give you this little, it's not really a formula, but kind of a template, if you will, for how to set up these problems. In this case, in this example, our center is 100. That's our ideal. Another way of saying center would be ideal. What is the ideal size? Ideally, this tennis racket would be 100 square inches. So 100 becomes my center. So I'm going to pick a variable. I'm just going to use x, and we're going to go minus 100, which is the center. I would like it to be ideally 100. But I'm also willing to fudge the 100 and be anywhere from 80 to 20, to 120, because I'm going plus or minus 20. So the distance from the center, the distance from my ideal, how far off of the ideal am I willing to be okay with this? I'm okay if it's 20 above my ideal or if it's 20 below my ideal. I'm not okay if it's 30 above my ideal, if that makes sense. So when I solve this, I'm going to get the answers of 80 and 120. So again, they're not asking us to solve this in our head because that would be easy. The answer would be 80 and 120. They want us to write and solve an absolute value equation. This is your absolute value equation. And now we're going to solve it. Our positive case is going to go first. And we're going to say in the case of the positive, we're going to go x minus 100 equals 20. We're going to add 100 to both sides. And you can see very quickly how we're going to get 120, which we already knew. Okay, for our negative case, I'm going to come over here. And for the negative case, we're going to get negative x minus 100 equals 20. Another way to do this, and if you don't want to distribute the negative, is to go ahead and divide by negative 1 right away. If you do that, then you're going to get x minus 100, because these two negatives are going to cancel, and you're going to get negative 20. And then when you add 100 to both sides, you're going to get a negative 20 to positive 100, which is going to be x equals 80. And again, we already knew that by looking at this mentally. But again, they wanted us to write and solve the absolute value equation. So we wrote the equation right here. That's the absolute value equation. And then we solved it, and we got x equals 120 and x equals 80. So those are our two values there. I think it asks us for the greatest and the least. So the greatest is 120, the least is 80. So don't be scared. You're not going to have to do a word problem right now for the do-it-yourself. But you are going to solve these two equations. And the key I want to make a point of right now is that when you solve these do-it-yourself problems, you remember that you have to have a positive case and a negative case. You should get two answers for each one. And make sure to check your solutions as well. Okay, so now we're going to go to some of the, I don't want to say bizarre, but some of the things that you can run into when you're doing absolute value. So this problem seems to be pretty normal. One of the things that I probably didn't mention earlier, but I should, is that when you solve absolute value, you have to make two cases. We said that. But you can't make two cases until the absolute value expression is isolated by itself. This is a situation where the absolute value expression, which is the part that's inside the bars, this guy, is not by itself. It has a +8 on that side. So before we can even split it into two cases, we have to subtract the 8. And I tell you that's a common mistake that people make all the time, and it causes a lot of problems. So please, please, please remember that you have to isolate the absolute value before you split it up. So then that leaves us with 3x plus 2 in the absolute value bars equals -7, and now it's by itself. At this point, this problem becomes kind of null and void. And the reason why is we said earlier that we already know that we are looking for a number x that when I times it by 3 and add 2 to it is going to equal -7. The absolute value of 3 times x plus 2 is supposed to equal -7. Well, this is impossible. It's not possible because anytime I have absolute value bars, it doesn't matter what x is, because if x times 3 plus 2 ends up being negative, the absolute value bars will automatically make it positive. Therefore, it is impossible for the absolute value to equal a negative value. So this is not possible, and it's never true. So we are going to say no solution on this case. So just want to have you guys be aware that that can happen. So make sure that you're being very careful, and that if ever you have the absolute value of something equals a negative value, this is never true, never possible. So the answer then for that problem would be no solution. So now we are going to ask you to do these two. And again, just be careful that if the absolute value equals a negative number, then there's no solution. All right. The other thing that can happen with absolute value sometimes is you can end up with extraneous solutions. Now, I will tell you, there is a way to kind of know when you will and won't have that situation. And I don't know if you've noticed this right now, but when we did example 2, the absolute value expression had a variable, and this one does as well, but it was equated to a number. So in this case, for example, you have the variable, and the variable is in the absolute value, and then it's equated to a number. It's not equated to another variable. And so in this case, you're not likely to get extraneous solutions. But what we have now is a situation where you have variable on both sides. The variable's inside absolute value bars, and it's outside the bars. It's on both sides. When you have this kind of a situation, it is very possible that you will get extraneous solutions. And what we mean by an extraneous solution is you do all the math correctly, you get two solutions, but when you plug those solutions back into the equation, you actually get a false statement. So it's like a false answer. So we didn't do anything wrong mathematically, but it just didn't work. We call that an extraneous solution. So let's begin here. We're going to start with our positive case, and I'll show you how to handle these extraneous solutions. The positive case is to take x plus 10 equal to 4x minus 8. Not a big deal. And now to solve the problem, you want to put the x's on the same side. This is very similar to things you've done in the past. That's 0, so you get 10 equals 4 minus 1 is 3x minus 8. Add 8 to both sides. You get 3x equals 18. Divide both sides by 3, and x equals 6. That is one of my solutions, supposedly. We will check later to see if it's actually the case. Then we go to the negative case. In the negative case, we do what we did last time. We put a negative in front of the absolute value expression. All right? At this point, you can distribute the negative. negative times x, negative 1 times x is negative x, negative 1 times positive 10 is negative 10. And then we want to bring this x to this side. So they cancel, you get negative 10 equals 4x plus 1x is 5x minus 8. Bring these 8 over to the other side. 5x equals negative 10 plus 8 is negative 2. Divide by 5. And x equals negative 2/5. All right? So those are our two solutions. But now we need to see if they're actually correct solutions. Do they actually give us true statements? So now we're going to go to the original problem and plug in the values that we got. So for the first part, I'm going to get the absolute value. I'm going to test the first answer, 6. So we're going to go 6 plus 10 is supposed to equal 4 times 6 minus 8. So what I've done is I've replaced the x variable in both spots with 6. So 6 plus 10 is 16. The absolute value of 16 is also 16. On this side, we've got 4 times 6 minus 8. And 6 minus 8 is negative, I'm sorry, that's not actually correct. Let me go back here. These little dude here, sorry. It's 4 times 6 minus 8. And that does make a difference. I had the parentheses in the wrong spot. So 4 times 6 is actually 24 minus 8. And then 24 minus 8 is in fact 16. So it turns out that x equals 6 is in fact a solution. That one's okay. But now we're going to try this negative 2/5 and see if that one works. So we're going to do the same thing, only this time replace the x with negative 2/5 plus 10 equals 4 times negative 2/5 minus 8. So we're going to do on the calculator, I'm going to show you how to just put it in parentheses, negative 2 divided by 5, close parentheses, and then we're going to add 10, and we get 48/5, positive, because 10 is bigger than negative 2/5. So basically 10 would be 50/5, and 50/5 minus 2/5 is 48/5. The absolute value of that, which of course is still 48/5. Okay? So on this side, we're going to get 4 times negative 2 is negative 8. So we have negative 8/5 minus 8. So we're going to get negative 8 divided by 5, negative 8/5. And we're going to subtract 8. And we get a very close answer. But what you'll see here is that 8 is actually 40/5. 40 divided by 5 is 8. So this is 40/5. So negative 8/5 minus 40/5 is negative 48/5. And you might be thinking, oh, they're the same. They have the same numerical value, but this is positive and this is negative. So no, a positive does not equal a negative. So in this case, this solution of negative 2/5 is extraneous. And you can abbreviate EXT. That is an extraneous solution. It's a solution that we got, but did not actually work when we plugged it in. And so in this case, the only solution that you end up with is x equals 6. So again, be careful and watch out for those extraneous solutions. So now you will have a chance to do this do-it-yourself problem. And once you've completed this little guy, you will have finished your notes for this lesson. I will see you in class. Thanks for watching.